Welcome to Great Source Code. So in this video we will discuss about tail recursion. So let's get started. So what is tail recursion? Tail recursion is a technique in programming that optimized recursive function to use less memory and run more efficiently. Tail recursion is nothing but a same as recursion but is in an optimized manner. Okay, when a function is tail recursive, the recursive call is the last operation performed before the function and return the result. The last function we will which perform it will going to give the result in tail recursion. This allows programming language to optimize the recursion process, avoiding the creation of new stack frame for each call. So why tail recursion matters? Okay, without optimization, like without tail recursion, normal recursion, where at every calling it's a new stack frame and which can lead high memory uses and stack overflow error. For deep recursion, tail recursion help by reusing the same stack frame, making it possible to handle large input without running out of memory. So whatever statement is written here, I will prove it with practical example after this theoretical part. Okay, so stay with this video. So here a simple example of tail recursion using scala. So here we are defined the tail recursion function and the base condition, and else we call the tail recursion recursively. The main point here, we are using accumulator while calling the function again. We are accumulate the result, and when we reach the base function condition, it will return the accumulated result. Fine. So how it's work, all the explanation is given here also, you can go through that. So why it's tail recursive? So in this implementation, the recursive call to a factorial tail is a very large thing executed in the function. There is nothing left to do. After this call written, which allows Scala to optimize the recursion by reusing the same stack frame for each call. This optimization reduces the memory usage and prevent the overflow, make it possible to compute factorial for a large number efficiently. Okay. So to understand more in more some graphical manner, just see this image. The first one is without how to optimize way, and with optimize, like it's normal recursion, and this is with tail recursion. So let's understand first this. From main we will call the factorial 5, it will call factorial 4, the number will deducted till reach factorial 1, then it will, once base condition is satisfied, then it will go back to calculate the result. Okay, so here there are multiple calling are there, because of that we will get the stack overflow issue. And with tail recursion, as I said, we are accumulating the result at each in every calling. Okay, we are accumulating all the result. So here from main to factorial to here, then in factorial 1 we are accumulated all the result, and we reach the base condition, and we will going to return the accumulated value. So whatever we are did here, once we will reach the base condition, we will return the accumulated result. Okay, so the lots some theory part is done. Let's begin practical part. So let me create some object in Scala. The name of object like test. So first let's understand the normal recursion, like without optimized way. Let me write the main, and I have to define my recursive function def recursive, and here I will take one input, and my return type should be in long, and here I will give my base condition if n less than equal to 1, then return 1, and in else and into recursive and -1. Fine, let me call that function. Let me print that function instead of that, recursive, and let's find the recursion of 5. Let me run that. 120. Okay, so this function is working fine. Let me create the function of tail recursion, like optimize recursion. Def tail recursive, and here I will give the input and accumulated value. I will give the in long, return type should be in long. So here let me write the base condition is equal to 1, and here I will return accumulated value. Okay, and else condition, first what I will do, tail recursion, and I will reduce the n, and I will calculate the value n. Okay, so let me call the tail recursive function. Here I have to give one more input, which is accumulated value as a 1 for tail recursion. Yes, so 120, we got 120 and it's working fine. So let me give some live example how tail recursion will handle the stack overflow error. So let me first copy that. Let me call the recursive function. Here it will accept one value. Okay, first let me give some big value here, like I guess first of all I have to change the written data type here, so it will support big value. Okay, so first 5 is working fine. Let me put some 500. Let's see it's working or not. Yeah, 500 is giving 0. Why 0? Because it's already reached that data type range. Okay, which is long range is already exceed. So in 50 we will get the value in minus something value. Okay, so when it will reach our range, so after that it will give 0. Okay, let me give 5000 input. Yeah, it's working fine. Let me do 50k. So here we get stack overflow in 50k. Okay, normal recursion. Let's move to the tail recursive. In tail recursive 50k. Okay, let me run that. So it's working with 50k. So hence I have proved that our tail recursion is optimized way and handle stack overflow much better than the normal recursive. Let me just raise the number here. Let's see how much number it will support. This is 1.5k million. It give me 5 million. So it supports 5k million also, means 10 times more than that. 10, not 10, it's 1 2 3 4 100 times greater than else. So it's very optimized way. And in scala, if suppose we have, if suppose some newbie has come and check your methods, they will not understand this is a tail recursive function or not. For that, scala there is one annotation in scala is tail recursion. So this annotation will tell if some new person is there that the given function is a tail recursive function. Okay, so yeah, so that's it from my side. I hope you got something new to learn. So if you are new, you can like, subscribe my channel. Okay, thank you.